Good morning, mathematicians. Happy Friday. It's Friday, March 27th, 2020. I want to show you I want to show you what you guys did yesterday and what you'll be doing today. So if you guys take a look at this sheet, this is actually what you guys were supposed to work on yesterday, and I worked with a lot of you guys this week. And what I noticed is that some of you guys are still not really understanding what the values are in the formula. So that's really the key to understanding everything. So a lot of this is just plugging and chugging. Your formula is y equals a times b to the power of x. A is always your starting amount. It's always the amount, it's always the first number in your table or the first number in your story. So, like if you look at number one, I'll show you how I set it up, but if you notice, it's always when x is equal to 0. So a 0 is, you always start at 0, and it's whatever that value is. So for example, in number one, the starting value is 256. So 256 is your A, because that's what you are starting with. I'm sorry. So then your B is always your rate of growth or your decay. So it's always kind of like your percentage, the amount that your population is either getting larger or getting smaller. And we'll talk about that a little bit more in just a second. And then your exponent is always their time interval. So it could be weeks or months or years, and it's always your exponent, okay? And your y is always your output of that particular situation. So if we started at this amount, we're increasing or decreasing by this amount over how much time, and that gives you your y. And I've given you guys the steps on how to do this at the beginning of the week, and I've given you this formula. So all you're doing is getting different situations where you don't really have a story, you're just getting numbers to crunch, or you have a situation and you have to do the exact same thing. It's just they're not listed, they're in a story, and you have to pull out the numbers. But there's really no difference, two sets of numbers. So, like for example, with number one, we know that you have two coordinates, 0 and 256, 4 and 81. Always start with 0. 0 is always your starting amount. So at 0, we started with 256, and then it jumped to 4 and 81, right? It's always x comma y. And so you can see that it's going from 256 to 81. I know yesterday morning a student was like, Miss Post, the numbers are going down. It's not increasing. And that's exactly right. This one is actually what we call a decay function. And you do the same thing as you do with the growth. It's just you'll notice that the numbers will go down instead of going up. They'll get smaller instead of larger. And you'll notice it because the growth rate, or in this case, the decay rate, is always going to be less than 1. So it's 0.75, and that's how you know the decay is going to be less than 1. So make sure that you guys are setting up your formula. You start with the last number that you have, because we know that 81 was our last amount that we had, and it took them I don't know if this is years or months or days, starting with 256. So you started with 256 and you had some kind of rate of decay to bring it down to 81 over a time of 4, whatever the 4 represents. You solve it like a regular equation, divide both sides by your leading coefficient, 256, and because it's b to the 4th, you have to take the 4th root. And all that is a fancy button on your calculator. And we before have talked about how it might look like this. It might just not even have a y inside it. It might be y to the x. It might be n with like an x or a y inside, something like that. Some of your calculators put like a box with the root symbol. It just depends on your calculator. Sometimes you have to put in in this case, once you divide 8 into 256, it's 0.32. Sometimes your calculators will make you put in 0.32 first, and then you put in the root button, and then you put in 4. Some of your calculators, you put in the root button, and then you put in the 4, and then you put in the 0.32. It just depends on your calculator. So that I don't know, because I can't see your calculators and I can't like mess around with them. You guys have so many different varieties of calculators. Usually in the classroom I play around with it and we figure it out, but I can't do that right now. So you just have to play around with it when I give you the answer, and then just remember which order you have to put it in to get that. And they're all a little bit different. Some of the Casios and the TIs and all the different kinds you guys have. So anyway, so for number one, it just says write an exponential function, and so that's your exponential function. Once you solve for b, it's going down by 0.75. So your rate's always inside the parentheses, and it's saying that if you start at 256, it goes down by a rate of 0.75. You can then use the equation to plug in different time values for x to get your y's. So you could say, well, what will it be when my x is 10 or my x is 15 or whatever you want. And you can get your output of y, okay? Two, you would do the exact same way. You'll just notice this one is decreasing. I'm sorry, did I say decreasing? This one is increasing because it's getting larger from 128 to 37,000. No, 371,293. I try not to put commas in there because I was trying to make sure you guys could see the different numbers. So a couple other things just to go over, like for example, number 3, it says Ahmed's consulting firm began with 23 clients. So it began with 23 clients. So you know that that particular coordinate is going to be 0, 23. That's the starting amount when x is equal to 0. And then in 7 years, Ahmed now has 393 clients. So when you start to set up your formula, you can go ahead and start it out with what you have. You have 393 grew from a starting value of 23 after 7 years. So you go ahead and set up your equation, solve it for b, and then you can just plug it back into your formula. That way you can use it for any other type of number values you need to get in the future. Once again, number 3, it just says write the equation. You don't have to do any other calculations. You can stop right there. The same thing with number 4. It just says write an exponential equation. The only not great thing about number 4 is that the numbers are really large because it's a population problem. So the numbers are just really, really large. So it's okay. Once again, it's starting at year 2000 and then you're moving to year 2008. So the older one is your starting value. So 2000 would be is your x value, and then at 2008 that's your second x value, right? And so you just put the two different populations here and go ahead and set them up again with your last population, like the growth, equal to the starting population over whatever many years that is, or to the power of however many years. In this case, it was 8 years. And divide by your leading coefficient. You know, when you do that, that cancels out the leading coefficient here. And then you'll have b to the 8th power. Once again, take your 8th root. When you divide these two numbers, the two populations, you should get 1.1. You take the 8th root, you get 1.01. So remember that 1.01 is your new rate. And it's an increase. Population usually goes up, right? Not by much, but in this case it is going up a little bit. And so you would just set it up like that, and it just wants you to write the equation so you don't have to do any other calculations. Number 5 was a little bit more work, but not necessarily. It just gave you two different people to kind of evaluate. So it gave you Ingrid and it gave you, I think my screen cut off. I might have to grab my other paper. It gave you Ingrid and it gave you Alberto. And so you all were to find Ingrid's equation and Alberto's equation for part A, and then B wants you to calculate, I think, in year 5. So then you would just go ahead and plug in year 5 at the end once you get the two equations. And remember, I set Ingrid's values up as 0, 2, because in 2000 she had 2 employees. I set Alberto's up with 0 and 32, because when he started, he had 32 employees. And then Ingrid's grew in 3 years to 50 employees, and Alberto's grew in 7 years to 310 employees. So now you kind of might want to think like, okay, well, which one had a larger rate of growth? Because their employee amount is increasing, so it's growth. And you can do that by finding the B. Whatever one has the larger amount. It looks like Ingrid's is 2.9 and Alberto's is 1.38. So that's hers is definitely a lot larger. Her rate of growth is definitely a lot larger. Just make sure you do the right root calculation. Hers is to the power of 3 and Alberto's is to the power of 7. And then once you get your two equations, part B says, I think it says find it in 2005. I think it said for both of them. So my screen cut off. Let me see if I can find this. Show. Yes. And I must not have calculated that one. No, I did. It's just right here. I think it's right here. Let's see. All right, hang on one second. Let me go ahead and pull that up. Okay. And then if you would have gone ahead and plugged in 5 for your exponents right here, because it tells you in 2005 to do that, um, you guys would plug in the 5 and you guys would see if we plug this in as 5 and this exponent in as 5 because it tells you in 2005 to do that. You guys should get an output for Ingrid at 410 employees in 2005 and for Alberto 162 employees in 2005. So it's interesting how it looked like he was doing better, getting more employees, growing his company, but ultimately it looks like Ingrid would end up with a greater rate of growth. So you guys can pause the video and write the work down and check your work. Hopefully I heard some, let's goes, and hopefully I heard some yes in the background whenever you guys were checking your work, because I really want to make sure that you were trying these. Hopefully by now it makes sense to you guys. You can pause the video and go back and look over these, but your assignment for today is to go ahead and go to USA Test Prep. I made an assignment in there. I picked and choose the questions for you guys is 5 questions, and then there's a bonus. They're just on these. Make sure you understand what the formula means, the y equals ab to the x power. You can do this with your notes. Just make sure you do it on your own independently. This is a 10-point assignment. It does go in this quarter 3. So that's due today. This will show up in your grade book in the beginning of next week. Probably Monday I'll have this in there, so make sure you get that done today. Next week is your last week of quarter 3, so this assignment, and then you'll have an assignment, another mastery assignment in next week for quarter 3, so make sure you do that. All right, guys, let me know if you need any help. My office hours today, right now they're just the same as that's been all week, but I'm probably going to shift them a little bit next week, but I'll be in the post office from 8 to 9. I believe it's 11. No, 10 to 12 and then 2 to 3 if you need help. Okay. Well, actually, I can't really help you with this, but if you have any questions about any of, like, if you wanted to go over any of the questions that I went over on the review, that's fine, but you need to do your assignment today on your own. All right, guys, happy Friday. Have a fabulous week, and thanks for working so hard on your math. See you guys later.